Okay, so here's some examples of different ways to multiply radical expressions. So the directions are usually going to be to simplify because you're not solving for a variable. So this one is pretty straightforward. You're multiplying two numbers without any coefficient or without any number out in the front. Here, you're multiplying and there are coefficients. There's a 2 out in the front and there's a 3 out in the front. And then here you have a radical monomial times a binomial, or a number that's you have a distributive property situation with this root 6 times whatever's in the parentheses. So let's just tackle these one at a time. And the goal, remember, is to simplify, and you could think of simplifying it as carrying out the order of operations and then putting the final solution into its simplest terms. So if I multiply these two numbers, the mental steps are that you can put these together as 2 times 10 under 1 radicand. Like, go back and look at the product property for radicals. So that ends up being root 20. And then when you try to break it down, factor that again, you're looking for two factors, one of which is a perfect square, or that can be simplified into a perfect square. So if I move this way, this root 4 becomes 2, and the root 5 stays exactly the way it is. And that's the solution to that problem. The second problem, one way to solve this is to think of the commutative property for multiplication. These are all multiplication. This is all multiplication. So 2 times root 20 times 3 times root 5. Well, if all of it's multiplication, then that means that you can move the terms around in whatever order that you would like, and it won't change the value of the expression. So here I decided to move the 2 and the 3 out in front. Now, if this was addition or subtraction between here, I wouldn't be able to do that. I would have to follow the order of operations. So 2 times 3 simplifies to 6. Root 20 times 5 can be written like that. So this turns into 6 times root 100. And you know the square root of 100 is 10, so it turns into 6 times 10. Gives us our final solution, or final simplification rather, is 60. Okay, the last problem, kind of an upper tier type of problem, is this single monomial times this binomial. And it's exactly the same process as you learned earlier in this term where you use distributive property. So I'm going to multiply the root 6 times the 5 and the root 6 times the 4 root 3. So if I do that, if I employ that idea, I have root 6 times 5 plus root 6 times 4 times root 3. Then if I rewrite the order, so in other words, I can switch the 5, I can call this 5 root 6 plus 4 root 6 times root 3. And then I simplify whatever I can for each term. So here's one term. Now if I could break down the root 6, I would, but I can't do that. Root 6 is as simple as it gets. Root 3 times root 2, there's nothing further to factor, or root 1 times root 6, there's nothing further to factor. So this just stays as 5 root 6 plus 4, and then when I multiply these together, I get 4 root 18, because 6 times 3 is 18. So one way to solve that Let's take 5 root 6 plus 4. Now I'm going to change, and I'm going to factor rather 9 and 2, because 9 times 2 is 18. And then what I know is that 4 stays the same. I'm going to multiply that times the square root of 9, which we know is 3. And root 2 stays identical. And so finally, I have 5 root 6 plus 12 root 2. And since these radicans are different, I cannot combine them any further. For example, I cannot make this 17 root 8 because those are unlike terms. It's very similar to the rule, whereas if I had 5a plus 12b, I can't put those together and make 17ab. Those are not like terms. So you treat the radicans as if they were variables. They have to be exactly the same in order for you to combine them.